Okay, so I hope that you gave yourself a good opportunity to work with that GeoGebra applet. It's nice to see or to be able to do it yourself and see what the changes are. And I hope that what you found was that in general, although the lengths of the sides of a right triangle may change as the radius changes, that the ratios of the side lengths remained constant. So what you saw as you moved things is that when we were dealing with a unit circle, we could say that the sine of an angle, for example, was equal to the y value, but what we didn't realize is that it was the y value divided by the radius. If we have a unit circle, that radius is 1, and so that's why it was just y. But the second that we go outside of the unit circle, dividing by something other than 1 is going to alter things. But again, the ratio remains the same. So here is my definition. For the point x comma y that we see on this circle, and notice that we have a radius of r, at an angle of theta, some theta in standard position, let the point be on the terminal side of the angle that is on the circle, x squared plus y squared equals r squared, then the following functions can be defined as the ratios of the sides of the corresponding triangle. So that x squared plus y squared equals r squared is our Pythagorean theorem. We've talked about that. And the reason we have a Pythagorean theorem is because of that line that was dropped perpendicular to the x-axis, creating the right angle. And by doing that, this side here becomes my a squared, or in this case my x squared. This becomes my b or my y squared, and this is my c or my r squared. So you can take a look at those. I think they are all filled in. Nothing has really changed. Sine before was just y, but now we're going to say if the radius is something other than 1, we have to make sure to divide by that. Same thing for this one. Now let's talk about tangent for just a second. Tangent is equal to the sine of theta over the cosine of theta. So if I take my y over r and I divide it by x over r, divide by x over r, we know that that's the same as y over r times the reciprocal. And you see that the r's cancel out. And so actually the definition for tangent hasn't changed at all. And if tangent hasn't changed at all, then cotangent hasn't changed. So the definition or the ratio for tangent and cotangent, whether you're in a unit circle or not, that ratio doesn't change. Going back to sine and cosine, if sine has changed, so has cosecant, and if cosine has changed, so has secant. Example 6. Suppose that the terminal side of an angle theta, when plotted in standard position, contains the point 4, -2. Find the exact value of each of the 6 trig functions of theta. So the 6 trig functions are sine, cosine, tangent, cosecant, secant, and cotangent. And what we know, or what I see in this example, is that we are not told that that point 4, -2 is lying on a unit circle. And so what that means is I have to make use of the ratios that were found on the previous slide. And let's just start with sine. Sine of theta was defined as y over r. And although I know my y value as -2, I don't know the r value. So off to the side, I'm going to go ahead and do that computation first. Let me just break this off. So what I know is that x to the second plus y to the second is r to the second. And so I'm going to write 4 to the second plus, I'm going to make sure to put parentheses around that -2, because if I don't, then I would not be squaring the negative. Maybe you remember this, maybe you don't, but there is a difference between -2 to the second versus quantity -2 to the second. The one on the left does not square the negative, the one on the right does. So these guys are not equal. Be careful about that and make sure that you practice it when you're writing out your homework problems. So this gives me 16 plus 4, and so I get 20. equals r squared. To find r, I'm going to square root. Now normally I would have plus or minus, but because we're dealing with a radius, that radius is going to be a positive value. And square root of 20 is a nice answer, but I notice that there is a perfect square number inside of that 20, 4 times 5. And if I take the square root of 4, that leaves me with 2, and on the inside I'm left with 5. All right, so that is my radius. So I'm going to put in 2 root 5, and to make that, actually let me just erase that and write this off to the side. I'm going to go ahead and reduce this. The 2 on the top and the 2 on the bottom cancel out, and I'm left with negative 1 over root 5. Now you'll notice up in the top a little help button popped up. That's because if you had any issues with how I simplified this radical, I'll put a star right there. There's a link that you can get to from the PDF that will give you some more examples of how you simplify radicals. The other thing that I need to do with this sine of theta is rationalize the denominator. And so I'm going to multiply by the square root of 5 over square root of 5, and that leaves me with negative root 5 over 5. Now, what I know is that the reciprocal of the sine curve is the cosecant curve. So let me just go ahead and take care of that next. Cosecant of theta is going to equal, in this case, r over y. Or maybe what I do is I just take this answer that I got for sine of theta and flip it. So that would give me square root of 5 over negative 1, which would be negative root 5. All right. Now let's go to cosine of theta. Cosine of theta is x over r, and my x value is 4, and my r value is 2 root 5. I'm going to simplify. So the 4 and the 2, let's see, 2 goes into 4 twice, and so that gets me 2 root 5, which I will rationalize to get 2 root 5 over 5. And I'll do the same thing I did before. I'm going to go ahead and go to the secant of theta, because the secant of theta is the reciprocal of the cosine. Remember these, we can remember these because they're opposite. This is a C and an S. This is also a C and an S, or an S and a C, you might say. So I can go ahead and plug in the r and the x, or I can just take the reciprocal of my cosine function to get the square root of 5 over 2. All right, now I'm going to erase a little bit here. Let me erase the work that I did finding the radius. Taking it a little while to erase. Sorry that took so long. All right, and let me find tangent. Tangent of theta is equal to, on the previous side, we said that that was y over x. And so my y value is negative 2, and my x value is 4. So I would say that the tangent of theta is negative 1/2. And finally, the cotangent of theta is x over y, which I'm just going to go ahead and take what I ended up with the tangent, and I'm going to flip it. So I get negative 2 over 1, which is negative 2. Notice that in all of these examples that all I'm being asked to do is find the sine or the cosine or the tangent of theta. I'm not actually being asked to find theta. So make sure that you got that straight in your head.